that's the countdown timer for recording this. All right, chain rule. Here we go. The chain rule says this. The first derivative of a composition function is you take the first derivative of the function of, and then you have the inside function times the derivative of the inside function. Now that's kind of the hard way of looking at it, and I'll clarify all this in a little bit. But that is the chain rule. It's a composition of functions where the outside function, you take the derivative of the outside function to the inside function, and then you take the derivative of the inside function and multiply that on the end. Okay? Now, the Leibniz notation. So y equals fu. Yeah. So know that. Kidding around. Where u is g to the x. So then the first derivative of y with respect to x is the first derivative of y with respect to u times the first derivative of u with respect to x. And you guys haven't seen much of this notation yet, so we'll get to that. We'll get to all this, and I'll show you how we get through that. Okay? So the first derivative of a function to the u power is the first derivative of the function to the u times du dx. And I know that doesn't make sense yet. I understand that. We'll work our way through this so it makes sense. We'll look at example problems and all that. Okay? So you can look at it as a composition of functions rule. And when we do the tables part of this, you need to know this end of it, not the Leibniz. I learned Leibniz notation, so I will revert to that more than I do this. So we'll get there. But when we do second semester, when we do integration, it's Leibniz stuff. So the u's and the du's are going to be heavily involved in that. Yeah. F of u, not fu. F of u.
Originated in English though?
No, it was originated in German because Leibniz is German.
And technically would not have inferred that.
But in 12th.
In a different language, it wouldn't have
So,
been that.
the next year. But anyways.
So are you going to take a calculus? You'll take a calculus class next year in Germany?
We don't really have calculus, we have just math.
Yeah, the next level of math. So, okay, are we ready to move on?
Yeah.
Well, some of you were writing it, some of you weren't, so that's fine. All right, so the cosine cubed of x. No, we're not even going there. All right. So what this is the cosine of x to the third power. So here we have the inner function, which is the cosine of x. And here we have the outer function, which is x cubed. Okay? So this is our u function. The inner function is our u function. So when we take the derivative of this, okay, we're going to do the outer function to the inner function and then take the first derivative of the inner function. So it's going to be f prime of u du, in my words. F prime of u du. Well, what's the first derivative of this whole function? Well, it's 3 goes out of the in front, And then the inner is squared. What is u? Well, it's the cosine of x times the first derivative. Du is the first derivative of u. What's the first derivative of the cosine of x? Negative sine of x times negative sine of x. So if we simplify this, it's negative 3 cosine squared of x sine of x. And that is the first. No. The negative here came out front. So then it's all clean when we do this. That's the first derivative of u. The first derivative of u is that x cubed, this whole thing. So we go there, keep that, and lower the power by 1. Yeah.
Anna, are you understanding this? Yes. Okay, great.
Okay. All right. So g of x, we need to rewrite that first, just like we rewrote this one, because cosine cubed of x is the same as the cosine of x cubed. This is just a rewrite is all. And we're going to rewrite g of x as 2x minus 9 to the 1/2 power. Okay? So I'm going to do the f prime of u du again, because that's how I look at things. What is u? What is u? 2x minus 9. What would du then be? Just plain simple 2. All right. So f prime of u. F prime of u is going to equal 1/2 times 2x minus 9. You don't change that to the negative 1/2. Okay? So then our final answer will be 1/2 times 2x minus 9 to the negative 1/2 times 2. Well, what's 2 times 1/2? They're going to cancel. It's 1. So it's really 1 over 2x minus 9 to the 1/2, or 1 over the square root of 2x minus 9. Yeah, we are going to allow, in my old, before I took my AP Calc training class, I always made them get rid of the square root on the bottom. They said, yeah, don't mess with them. That messes with their minds too much. So I have stopped doing that now. So we may leave the square root on the bottom here, because Khan Academy will show the square root on the bottom as one of the answers. Now, will they always do that? No, sometimes they will multiply top and bottom by the square root of 2x minus 9 and get the square root of 2x minus 9 over 2x minus 9. That's not that hard. No. Okay. So, are we all right with this? This is the beginning of the chain rule. Can you get what we're doing so far? Okay. All right. The power chain rule, which is a mix of the power rule and the chain rule. So u is not just x. It's a function of some sort. So the power chain rule says, well, you put the number in front to that, and you lower the power by 1 du dx. That's basically what we did up above, right?
Sure.
Because we did put the number in front, the original function, minus 1 to the power, and then took the first derivative of the inside. Basically, that's what the chain rule is. Okay? That's what the basics of the chain rule is. Now, what we do is we get really complicated with this, and we put the chain rule inside of the chain rule.
No.
But that's just for after we get this down a little bit better. Okay?
Guys, we have to die for now.
All right. So let's look at this function. Okay? So this is the chain rule. Okay? So we have to take the first derivative of this times the first derivative of this. Because it's just the first power here. So what's the first derivative of sine? Cosine. So this would be the cosine of negative 3x squared minus 3x plus 7 times the first derivative of the inside, which would be negative 6x minus 3. Boom. Nope. Because it's the sign of that, it's not assigned to a power. If it's assigned to a power, then you would. But if it's assigned of a complicated thing, then you just do that. Basically, which would make it assigned to the 0 power, which would make it 1, and so that would disappear times the first derivative of all that. So yes, Trey.
So you're taking the first derivative of the thing outside the parentheses,
Mm-hmm.
and you're keeping it the same, and then you take the first derivative of the apple. I'm
Yeah.
just making sure I
Yeah.
understand.
Yep. This is the answer. We're done.
That's it?
Then that would be the chain rule inside the chain rule, which I. It is really kind of sine of x. Like this is the sine of x. What's the first derivative of that? Well, it's the cosine of x. Okay. But since the x is very complicated, it's the cosine of the very complicated thing times the first derivative of the complicated thing.
What's the difference between this one and the other one? Because I don't.
There's not much difference.
Yeah, I'm not.
There's not much difference. I'm just showing. Okay. Yes. When it's like this. Okay, let's do the power chain rule to this one. This could be quick. So, power chain rule to this. What is the final answer to this? 5, parentheses. 5 minus 6x to the 4th times negative 6, the first derivative of the inside. So it's negative 30 times 5 minus 6x to the 4th. Boom. Okay. Okay. The table problems, which I don't personally like very much. No, we're not taking them out because AP might have some of these on there, so we need to understand this. Okay. Yes, we do. Yes. Positive. Okay. So, doing this, if we want to find f of g of x, it is f, or it's the first derivative of f of g of x times the first derivative of g of x. Okay, so if we're doing f prime of 4, so g of x, what is g of 4? Negative 2. So we're taking the first derivative of f at negative 2 times the first derivative of x at 4. Okay? Because the first because this g of x of 4 is negative 2. So we have to take that first derivative of negative 2, but then for the outside part, that still pertains to 4. So first derivative of f of negative 2 is right there, 1. The first derivative of g at 4 is 8 times 8. We get 8. That's the tables version.
Wait, how did you get f of the first derivative of -2 as 1?
Damn sure.
At -2, the first derivative of f is right there, 1. And then 4, the first derivative of 4 of g is at 8. Okay, so let's do the next one. Now that you saw one of these, now that you've seen one of these, the first derivative of f at g times the first derivative of g. Okay, so what is g of -2? What is g of -2? 1. So you need to find the first derivative of f at 1 times the first derivative of g at -2. What's the first derivative of f at 1? 4. Steve, don't go so far ahead of us, please. You're confusing people. All right, the first derivative, 4. And as Steve said more than a minute ago, it's 16.
That actually isn't that complicated.
No, that isn't super complicated, but to see it, sometimes some people just don't see the route that we take.
So, where are you getting like from the f to the parentheses g of x? Where are you getting like the f to the 1, g to the x, g to the 1?
Because that g to the x doesn't have a derivative symbol on it. Because it's the first derivative of the normal g of x. Well, the normal g of x at that point, -2, is 1. So then we replace g of x, the normal, with a 1. And so now we're taking the first derivative of f at 1. Yeah, but that's how you do it. But yeah, that's an explanation, but that's how you do it.
I just was trying to figure out if you like added that.
What?
How did it just happen to match up? That there was a x, that there was a 1 of x. Is that always going to happen?
They do that so they don't have a whole chart full of numbers that you can just pick from the. It'll be there for you. Yeah. Okay. So. So, what this is note card stuff. This is stuff that you can put on your note card for the next test.
Do we get it on that?
Do we get the extra large ones?
You do not get to use note cards on the AP Calc test, sorry. When it comes to that time, hopefully you'll have these memorized.
Who gets to proctor the test?
Mr. Shaw.
Not you.
Not messing around.
No, the one guy can't ride. I ain't above that, dude. I don't even go. I'm not even going to go. I'm not even going.
What part do you want us to write?
I want you to write everything that's up there onto these note cards.
That's awesome.
This stuff we covered last time. This is what I put on the board last time. Okay?
We
And-
did red too.
And then I want all of this stuff on your note card.
Can I also put that number stuff? No, not other stuff. Right side.
This stuff?
Yeah.
Yeah, this should go on the note card. That's your trig ones that I want there, because when we get to the inverse trig ones, they're totally different, and we'll add those to the note card too. And then ddx means taking the first derivative. I hope you know by now. Alex Collins, right. Yeah, well, that's what everybody in this freaking room is doing right now, is writing this down. Let's go. So ddx, as you know right now, is taking the first derivative. And so we're going to run into some of this today too.
This is the only thing we're
We still
doing,
teach you.
What?
Can you zoom in just a hair?
if I zoom in, then some of the stuff will go off the screen. So do you want me to go like this? Where do you want me to zoom into? On the left, black. Just relax.
Can't relax.
Sorry, I take advantage of
It's like
the
reading
mess.
Latin.
2020 vision.
Okay, so this is where we started, right? This was the first thing on there? Yeah. So the first derivative of e to a complicated function is e to the complicated function times the first derivative of the complicated function. Because everybody knows that the first derivative of e to the x is e to the x.
Yeah.
But when it's a complicated function, then you have to do that. Everybody knows the first derivative of the ln of x is 1 over x, but the first derivative of the ln of a complicated function is 1 over the complicated function times the first derivative of the complicated function. Chain rule.
What it's called? The complicated function.
Well, I'm just saying it that way so you understand. It's just of the function.
Oh,
But
no,
we're
I got you. I was just wondering.
Yeah.
Mm-hmm.
The logarithm we have not seen yet. That'll pop up today. A to the x we haven't seen yet. That'll pop up today.
This is like what math gives me.
What?
This is the only thing we're doing today, right? We don't got like another lesson after lunch.
No, I'm taking you through everything today, but there's a lot of stuff after lunch to do on Khan Academy. It'll take you probably more than just after lunch to do it.
So the log function, derivative
I
of
need
that
to
is
see the
just
rest of
1
it.
over x the ln of a.
Right here.
Can you?
Yeah.
Yeah, I can scroll down now.
And if you put a complicated function instead of x, it just means a complicated function instead of x.
Just zoom out a little bit.
There. Let's just do. We've got.
Bottom, like
This should be the bottom of this side.
What is, oh, a is supposed to represent a number.
A's a number, like a constant, like 4 to the x power. So the first derivative of 4 to the x power is 4 to the x power times the natural log of 4.
So who invented calculus?
Gottfried Leibniz and Sir Isaac Newton, both of them at the same time, separately.
At the same time, separately.
At the same time, separately.
There's no way.
Yes.
They came up with the same stuff.
They came up, well, their notation was different, but it's same concepts, yeah.
I don't understand how you can, like, how do you teach math without going crazy, Mr. Bishop? Like,
I am already crazy though.
like, I would lose my mind if I had to teach this all the time.
All right.
what makes you like so weak about this?
Could you try to scroll up a little bit?
Have you ever seen this?
Like we don't understand.
Oh, okay, that's fine. Hit submit again. I just wanted to.
Why is
Make sure you had everything.
Why is there a natural log in there for that one?
It's because it has to do with the slope of it. Because derivative is slope. You gotta have it through your mind. Derivative is slope. So if we looked at 2 to the x function at 1, the slope would, we can go through that later. But all right, make sure these are written down as well. Those you were supposed to kind of know for last time, but I threw them on the board for you. I'm letting you have them now, but because they'll come up again and you'll want to just look to your note card, which is easier instead of guessing or whatever. But when it comes to the AP test, you do not have note cards.
I like to see
If,
those, but I
yeah,
don't
the
like
first
that.
derivative.
I'd
This
like
is
to
the
see
first
someone
derivative.
who
You just don't see that mark up there. It just,
who got a 6 on this test. I would love to meet someone who got like a perfect score on this test because is that even existent?
well,
Give me 6 months.
Kevin Sean got a 5 on it.
That's the kid that got a 36, right?
What?
That's like
ACT perfect score is 36, and he got a 36 on his ACT.
Yeah, that's about me. Only about
You got
What's the average? Like, what's the pass rate, would you say?
Harvard
Pass rate?
Yeah.
We looked that up earlier. Pass rate for AP Calc with 3 or above was 40-some%, I think,
Whoa.
nationwide.
A 12.
No,
Three or above.
3 or above.
What's like? What would you say is like?
You wanna go back to the other ones?
Is 3 average for that?
I'm
Or?
missing last.
Just let's make sure everybody gets it down. Obviously, this column is the first derivatives that you should have understand that because we've had this already.
Right.
Day before the AP test, watch every single video recorded.
Oh, yeah, no.
Even if it's 25 hours.
Okay.
Whoa.
Whoa. Okay.
I got it. I'm done.
Can you go back to the other ones?
Not yet, because people behind you aren't done yet with these. Yeah, I know you're good.
I'm almost through like half the videos, I think.
Mr. Bushbuck, should we take the test?
That's up to you.
Wouldn't it
Because
achieve, like nothing for all of them?
yeah, it wouldn't get her anywhere as far as
Like
She's
college.
college.
like,
Fun.
For fun.
Fun.
You're
Oh.
Yes.
I took the
Bushbuck,
AP
we
Calc
paid
test.
for it.
Well, actually, no,
Fun.
that would kind of be a flex to be like, I got like a 3 on it. I feel like, or at least.
But what does a 3 mean?
It means at certain college you don't have to take the calc class if you get a 3. Other colleges make it a score of a 4 so you don't have to take the calc class.
How do you get a 3?
A 3 is they have a scheme of what their numbers are.
Oh, okay.
It's a rating score basically. We'll talk about it second semester. Okay, looks like we're done with this. What else did you need over here, Anna?
Not him, because your name's Akira, right?
The log of a f of x. Yep.
Fair point.
True.
That's your wallet.
You should be like, you should create a new one.
Yeah.
Like, can you plug this
Don't
in
say
your
that,
calculator?
Eli. It's not.
Not a graphic calculator, no.
Actually, it's gonna be like.
Okay. Are we ready for a little bit more? This today is a little bit intense, and you will have some outside homework you hardly have any outside homework. Well, today you probably will have some. Yeah. Friday. Because Friday we're going to take a quiz over this stuff.
That's a good one. I like that.
It's a Khan Academy quiz. You get to take it multiple times, you know.
Like Friday, as in next class.
All right, here we go. All right, so let's say we have the ln f of x equals the ln of 5x minus 2.
What is this?
Shh, Alex. So the first derivative of this, well, what's the first derivative of a natural log? 1 over x. So it's 1 over the function. So the first derivative of this would be 1 over the function, 5x minus 2, times the first derivative of the function, 5. Easy peasy. It's 5 over that. Yeah. Yeah.
Oh, so that's because it has length or whatever.
Natural log. Okay.
From now on, Alan is called.
I never have said natural log in my life.
Yeah.
Remember you couldn't say sine or cos?
Yeah, you
All right. If our function is e to the 3x squared minus 2x plus 5, What's the first derivative of that? E to the 3x squared minus 2x plus 5. You aren't listening and you're missing out.
Times 6x minus 2.
You want me crazy?
Oh God.
You won't like me.
No.
You won't like me when I'm
Okay.
Okay? Are we good with that?
Yep.
You see where we get that everything from?
Yeah.
Okay? E's are really easy. Okay?
I get that.
9 to the 2x minus 5.
Oh, so that would be 9 to the 2x. No. 9 to the 2x minus 5. Ln is 9
Times.
times 2.
There you go.
Wait, I'm lost. What? Oh, it's the A thing.
It's the a to the x. A to the x. The first derivative of a to the x is a to the x times the ln of x, a. And then if x is complicated, you take the first derivative of that. That's the first derivative. That's how you write it.
Huh? You literally did say Q.
I did not say q. 9. Yes, Trey.
How do you know that's the A formula? Why can't you just
A formula.
I know, but is it because it's the next one? The A represents a number.
Yeah, because this is a number. Otherwise, it would be a variable as a base. But if it's a number, it's the a to the x thing. All right, Allie, question or just stretching? Okay. Okay.
Reminder that the intersection of Washington and Northeast Ninth is closed. Do not cut through the DSU parking lot. If you do that, we will be flexible with you, obviously. We can get you back here, but I would take the big.
Log base 4 of 2x. Log base 4 of 2x. All right, so we go up to the log. So it's 1 over 2x times ln of 4 times 2.
So then can your 2's cancel out?
Serious question. Why?
Yeah, they will.
Why?
What?
How come there's two equations for log? Like, what's the difference between?
It was just plain and simple log of x. Log of x is just x ln of the number. Well, okay. Log base 6 of x
Oh, so just not.
is just 1 over
So if it has like a
x ln of 6. That's what it is.
Okay.
But if it's complicated, then you have to take it times the first derivative of that. And Alex said, don't they cancel? And I said, yes, they do, Alex. Yes, they do. That's the final answer. Because the 2 on the top cancels with the 2 on the bottom out front. If it was the 4 and the 2 can't cancel because this is a whole number and this is involved with a natural log, not a whole number. Okay? It's just what happens. Because when you take the derivative of it happens to go to a natural log. It's crazy how it works. I mean, well, I could spend 45 minutes proving that to you. Yeah, I don't know. Log naturale. We're dealing with German and whatever else. Okay, so we are done.
That's it?
That is it. So you guys get to work on Khan Academy. There's 21 things.
I'll definitely be here instead of watching tomorrow. Hey, Bebop. What class do you have first block?
First block is geometry.
Are you less likely to be busy?
I'm busy the first 40